If you look at the equation of a progressive wave, we are going to consider the waveform which is shown below. So you can see that on this axis, we have the displacement from the rest position. This is the rest position here. This position here is what we call the rest position. So on this axis, we have time. So you can see how the wave is vibrating with respect to time. So the distance from here up to here, this distance lambda is what you call the wavelength. So if the oscillation of the particle at O is simple harmonic with a frequency f and angular velocity omega, then its displacement y with time is given by y is equal to a sine omega t. So at point O, the wave, because the sine curve is zero, when the time is zero, the value of y is zero according to the sine curve. So meaning that the wave exhibits a sine curve, which is given by the equation y is equal to a sine omega t. So a is what we call the amplitude, omega is the angular frequency, and t is the time. So it is, this equation relates time with the distance which is traveled by the wave. So suppose the wave generated travels towards the right. So if this wave is moving to the right, so meaning that it is moving this side. So the particle at point P here, this particle at point P, which is a distance x, as you can see, the particle is a distance x. From O, which is the origin, will lag behind by a phase angle phi. So the particle lags behind by a phase angle which is given by phi. So that means that if the equation originally at point O is this, now the equation will be y1 will be given by a sine of omega t, since the particle lags behind by a phase angle phi, so meaning that the angle here will be less by a value phi. So from the figure above also, if you are to determine the value of the phase angle, we know it that when the angle is 2 pi, when the angle is 2 pi, that is when it is a complete revolution, or what we call a complete oscillation, the distance covered is equivalent to one wavelength, which is lambda. And then when the angle covered is phi, which is the phase angle, the distance covered is x, as you can see from the diagram. Phi, the distance covered for a phase angle phi is x. So if we make phi the subject of the formula, we end up getting phi as being equivalent to 2 pi x divided by lambda. So that is the value of phi. So we also know that omega, which is the angular velocity, is given by 2 pi f, and we know that f can also be given by 1 out of period, so this can also be the same as 2 pi out of period. So if we substitute for this and this in the general equation of the line, which was y1, the line moving to the right is y1 is a sine omega t minus phi. So if we substitute for phi and also substitute for omega, we end up having the equation as this one here. So the equation, if we rearrange, actually we can have it as this. So if we rearrange it, it will end up having it as this one here. So this is the equation of a wave which is moving to the right. So you can either write it like this, or you can write it like this upper equation there. So if the wave is traveling to the right, the equation is basically represented by this one. So this is the general equation for a wave moving to the right. So if the wave is moving to the left now, this wave will always lead the vibrations at the origin, and that implies that now we have this time to add on the phase angle. Instead of subtracting, we now add the phase angle. So it will be a plus phi, and if you solve the equation, you end up having the equation like this. So basically, you should have this into consideration, that this wave here, which has a plus, the phase angle, this one is traveling to the left. Then the equation which has a minus, where we're subtracting the phase angle which lies behind by a certain phase angle, that equation is always for a wave which is traveling to the right. So let us look at an example. A displacement of a wave traveling in the direction, x direction is given by y is this. So meaning that from the equation alone, we can clearly see that this wave here is traveling to the right. To the right reason because of the sign here. So we can clearly see that the equation is traveling to the right. So they want us to find the speed of the wave. So in this case, what you do, we just compare coefficients. We compare coefficients of this equation and the general equation of the wave, which is traveling to the right. So meaning that if we compare, this is A, this is A, this is 2 pi, this is also 2 pi. So this means that T out of T, this will mean that T out of T will also be equivalent to T out of 0.5. And this will mean that the period capital T will be given by 0.5 seconds. So if you also compare X out of 0.2 with X out of lambda, which is the wavelength, you end up getting the wavelength as being equivalent to 0.2 meters. So if you have period, you can get frequency because we know that frequency is the same as 1 out of period. So meaning that the frequency is given by 1 out of 0.5. So this is frequency. So if you also have wavelength, then you can find the speed V by using speed is given by F lambda, which is the equation of a wave. So finally, you end up getting the velocity as this one here. So take note of the units that you're given this time. The wave is in meters, or the displacement of the wave is in meters. So meaning that we are dealing with standard units in this question. And the second question is here. So still this one, we just need to compare. You just need to compare with the general equation, which is y is equal to a s sine 2 pi, s sine 2 pi into small t divided by capital T minus x out of lambda. So if you want, you can improve this equation such that it becomes y equals to a sine 2 pi t out of t minus 2 pi x out of lambda. So meaning that even this one here, you just have to multiply this with this and also 10 with x out of 100. And then you go ahead and compare coefficients. So if you do that and compare coefficients, so you end up having 2 pi ft being equivalent to this, and then 10x, and then 10x out of 100 will also be equivalent to pi x out of lambda. So from there you can obtain wavelength, and you can also obtain frequency, which you use to find the speed of the wave. The third example is the displacement in meters of a plane wave. P is given by this equation. Find the wavelength of the wave and the speed of the wave. So it's all about comparing coefficients and rearranging the formula. So you rearrange the formula and you compare coefficients to get your answers. Rearrange the formula, compare coefficients, you just get the answer as you are required. So here are some of the questions which you can try out in your own free time. The answers are also given there. So try them out and see whether you get those answers that are given for these questions here. Okay, so otherwise, that's it about progressive waves. Contact us to in case you have any questions. Thank you.